All right, great. We'll get started. Happy Monday, and uh, I renamed the Friday's lecture. Some stuff happened on Friday; it's suddenly canceled. So I appreciate your flexibility there. So anyway, renamed it to Week 3 Monday, and here we are. So we left off on Wednesday of last week. We introduced lists, and there were quite a few methods associated with lists, and I had to kind of rush through it a little bit. So we'll take a closer look at lists, and we'll also look at strings. And even though lists and strings feel like they're totally different, in Python, they have a lot of similarities in that they are both treated as iterables, okay? A list, we think of like you have, a number and a string and this and that. You have like a bunch of different kind of stuff. Whereas a string, it is a string, but Python also kind of looks at all of the characters in the string as like different elements that you can kind of iterate through. So there are some similarities there. Also, I'll post up a homework assignment, so you can look forward to that. Okay, let me go ahead and clear all of my outputs, and we will kind of look at what the lists do. So hopefully by now we're comfortable using Git to pull any changes and update that. If you're encountering issues with Git and whatever, like you're getting merge conflicts and stuff like that, come see me in office hours. I'll help you try to get that resolved and whatnot. Okay, so anyway, we left off, we said lists are mutable, and I think we ran through these examples, and I said, here is a list. We're going to define it as fam, and we have these things in it. And if you just take another name and you say second equals fam, these two names, second and fam, are both pointing to the exact same object. They are two names for the exact same thing, and therefore, if you modify an element within the list called second, the name fam points to that exact same object, and therefore, when you ask what is fam, it also has been modified because these are just two names for the same thing. Okay? If you don't want this thing where both second and fam, those names are pointing to the exact same thing, you have to create a copy. And so here I create the object fam, or create this object which is a list. I give it the name fam, and then I create a copy. And using slicing notation, if you just do blank colon blank, that's going to create a copy. It's technically called a shallow copy, but it creates a copy of this list. And therefore, now when I change or modify the zero index element in this object second, it does not modify the object fam because these are two separate things. One is a copy, and so modifying one does not change the other. Okay. You can also make a copy using the copy method. So here, if I take fam and I do fam.copy, that creates another object in memory, and that's also going to be a copy. So all of these things here, I'm just all of these little code chunks or code blocks. I'm modifying a thing. I'm printing out the original object. I'm modifying something in there, and then I'm printing out, the copy, printing out the original thing, and you can kind of see how, in one, the element has changed, and the original is unchanged here, okay? Another way to kind of create a copy of a list, so this only works if it is a list, is to, you can call list on the object itself. This is probably not the recommended way I would make a copy of a list. I would use, probably the recommended way to make a copy is to call .copy, but also square bracket notation with a colon is also a fairly common way people make copies. So I would say this method and this method are probably the two most common ways for making copies. So we have that, okay? And then as well, list slicing can be used in conjunction with assignment. If you needed to modify or change multiple elements in there, you can do that. I think we already looked at these methods. So we've seen the copy method, and then we also saw the append method. append adds items, adds something to the end of a list. So I can take the existing list, I can append, in this case, the string me to it, and that modifies the list. You can also append things by using the plus sign with another list, and that kind of concatenates two lists together. It just kind of joins them together. One thing about the plus operator as far as joining lists to kind of extend the list is that that operator itself does not modify fam. So over here, if I did fam.append, fam gets modified. Over here, if I do fam plus 1.8 inside a list, it does not modify fam. If I want fam modified, I have to assign that back to the name fam so that this new thing has the name fam, okay? So I can do all of this. And then anytime you do append, it always appends it as one item. And so here I have a list with a whole bunch of stuff. And so that puts the entire list as one item within the list, okay? And so if you want to actually extend the list, you would use the plus operator there. And then you can take a list and do ×2. All right. And when you do a list ×2, it basically takes the list and it adds on the list, and so it basically doubles the length of the list. It doesn't go through. So in your head, you might have thought, like, if I have a list of 3, 4, 5 and I do ×2, you would get 6, 8, 10. But you're not going to get that. If you have a list of 3, 4, 5 ×2, you're going to get 3, 4, 5, 3, 4, 5. So multiplication of a list just basically duplicates the list and extends them. This is a little bit of an aside, but in Python, there is something, when you create copies, it generally creates what's known as a shallow copy, okay? A shallow copy. And there's also a method called a deep copy. and so here is an example of the difference between a shallow copy and a deep copy. So lists can contain all kinds of objects, including names of other objects. So here, I'm going to create a list called C, and list C contains an object A and an object B. Object A is a list with the values A1, 2, and object B is a list with the values B3, 4. Okay, so here is a list called C, and list C contains names that refer to object A and object B. So here's A, here's B, and here's C, which contains object A and B. Okay. A shallow copy, all right, copies the references. So here, D is going to be a shallow copy of C, right? And then E is going to be a deep copy. You have to import the copy method or copy library or package, and within that you have deep copy as a method. Shallow copies copy the references. Deep copies create copies of those objects themselves. All right, so what is the difference here? Okay, so at first glance, D and E look like they are the same thing, okay? But D contains a reference to object A and object B. So what I'm going to do is I am going to take list C. Remember, C right now as it stands contains object A, object B. And what I'm going to do is I'm going to append the string X to C. And so what I'm going to do is I'm going to print out C. And so what we will see when I print out C is going to be object A, object B, and the string X. D is a copy of object C. So D is not going to contain that string X because here I'm only modifying C by appending an X to it. And E is a deep copy of C, so that too will not be modified, okay? So here C has object A, object B, which is the list, and it contains the string X. D was a copy of the original object C. E is a deep copy of the original object C. And so these things reflect what object C looked like before I appended X. Okay. This is the difference between the copy and the deep copy. This is going to become more apparent here. Okay. Remember, C contains a reference to object A. D is a copy of C, and D is a shallow copy of C, so it contains a reference to object A and a reference to object B. What I'm going to do now is I'm going to modify object A by appending the letter Z to it. Okay? And so here I'm going to print out what C is, print out what D is, and print out what E is. Okay? And so here we can see object C contains object A, which now has A, 1, 2, and Z in it. It contains object B, and it contains X, which we appended in this previous step. List D, which was a shallow copy of C, contains the reference to object A and the reference to object B. The reference to object A, well, A now has that letter Z appended to it. So it contains A, 1, 2, and Z, and then it also contains the reference to object B. Okay? Whereas when I created E, I created a deep copy of C. So it created, it saw C contained references to other objects, and rather than just copying those references, it created an entirely new copy of those objects themselves. So it created a new list, A12. So there's no actual name for this list that contains A12 in object E. Okay, it is an object in memory, but there's not like its own name. It is referenced as basically the object within E that that looks at this object here. Okay, but it is not. It doesn't have the name A or anything like that. Okay, and so when we ask what is A is this object itself right here within memory. This list that both list C and list D reference, which is this memory object in memory, the list there. Okay. So take if you need to review these notes to see if you understand. Make sure you understand the difference between copy and deep copy. Most of the time in Python, when you create copies, it's just going to create shallow copies. And a lot of the times it doesn't even matter. It's just if your objects contain names of other objects, just know that it's just copying the references, okay, to those names, which is often what you want anyway. So shallow copies is often the behavior that you want. But if there is a situation where you don't want that behavior, where it's copying the names, and you want actually your own like deep copy, then you've got to do it, a deep copy, right? So it's yeah, question.
I'm a little confused how E doesn't print out C.
It doesn't print out what?
The append from C to modify.
The Z?
No,
from 23. Because E, D and E are both copies of list C. So list C started off as containing reference to A and B. And then so here I'm creating a copy. D is a copy of this, E is a copy of this. And so when I change list C up here, it's not going to affect D and it's not going to affect E, right? It's kind of like you took someone's, I don't know, paper, you made a photocopy of it, and then that original paper, somebody scribbled on it. Your photocopies that you created aren't suddenly going to get updated, right? Yeah, question. Both of you, whoever.
So just to clarify, so if you do a shallow copy of, like, let's say you did a shallow copy for C, then it doesn't point to C, but it points to A and B, because A and B is inside this one.
So C contains, C is an object that contains the names or references to object A and object B. And then when you create a copy of that, a shallow copy, it creates another list with kind of the same references. Yeah. So they're all pointing to those same objects. Yeah.
Why does the string A and the string B, why does it appear as a character instead of a string? No.
A string and a character are the same thing.
Same thing.
Yeah. This is a string of length 1. Okay, insert. Insert basically takes an object and it inserts it into this index position. All right, so here you can think of it as inserting it into the comma position. So here you can think of look at comma number 4, and Joe will get inserted there. And so this object Joe will become the new index 4, right? So here 0, 1, 2, 3, 4. Joe is now at index position 4 is when you do that. Insert is only able to insert single objects. So if you want to insert multiple things, here I'm putting in Joe and 2.0. It's going to put this entire object, a list containing Joe and 2.0, into index position 4, right? So index position 0, position 1, position 2, position 3, index position 4 is this entire object. If you wanted to put Joe in position 4 and 2.0 in position 5 or something like that, you can't use insert, okay? That results in an error. There's something you can do extend, but that only always does it at the end. But what we can do is we can do assignment in conjunction with slicing. And so we can take this list, which contains Joe and 2.0, and we can assign it to the slice 4:4, which is basically at the 4th comma, and it will basically insert those values into that position, but not as a single object. It will kind of iterate through all of those things. So Joe would get into position 4, and 2.0 would get into index position 5. So these are, so I think this is a fairly common operation, and you should learn this, I guess, Python idiom or Python expression as far as this is how you would go about doing this. Because if you're looking for a method to try to do it, and you're thinking of insert, the insert only lets you do one kind of thing. Okay, here are some more methods, handy methods. Oh, let me give you, or actually I gotta log in to look up your view quiz answers. Okay, you wanna take objects out of a list. Okay, you can just call remove and it will remove that. That's pretty straightforward. If you have multiple matches, so here I have a 1.71 and a 1.71 in multiple places on the list, removing will only remove the first match, okay? So the other thing remains. Let's see. Okay, pop. If you have a list and you call pop, it's going to remove the last item in the list. Okay, and actually it will return that value. So you can assign the result of list.pop. So here I'm gonna pop. I'm gonna just call pop, and it's gonna basically remove 1.89 from the list. But it's going to return that, and I can capture that value. So here, if I ask, what is J? J contains that value 1.89, and then fam returns everything but the value on that position. Okay. If you don't provide any arguments, pop kind of acts like a stack. In that, if you have a stack of papers, the last thing that got added to the stack is going to be the first thing that gets popped off. Versus here if you put in, you can also put in an index position and it will pop the value at that index position. So here I'm going to do pop 0, index 0, and so in this case, if this is my list and I pop the value at index position 0, it will pop the value Liz, and so Liz will get returned, and then the list has that. So that will be kind of like a queue. The first thing, basically the bottom of the stack here is going to be the value that gets dealt off. You can also clear out the contents of a list, and you can do that as well. So if you want to, you might be like, why would I ever want to do this? Why don't I just create a blank list, right? But remember, lists themselves are mutable. And so you can always you could be referencing this object, this thing called fam, and you might have references to this thing. And if you want to actually have that cleared out to be emptied, okay, you would call fam.clear, or that list name.clear, right? So, going back to this copy thing, if you actually want to clear out the contents of this object A, you could do a.clear, and it will clear it out. Versus, it's very easy to create a new empty list, but that's a new empty list, and the old objects in memory still contain all of that stuff. So if you want to actually clear those things out, there's the clear method. Okay, index will return the index of whatever object that is. Okay, so I've got fam.index Emma here. So it will say, all right, what is the index of this thing Emma, and we'll get the number 2. Okay, you can also if we ask for, say, what is this? All right, what is the index of the value 3 here? It's going to say I couldn't find the value 3 in this list, and so we get back an error. It says 3 is not in this list that you are asking for here. All right, let me go ahead and give you your first view quiz answer. Today's first view quiz answer is the letter A. So let me go ahead and a list.count will go through and count how many times a certain value appears. So here I've got a list containing A, B, C, A, and I can count how many times does A appear. And it says it appears 3 times. Okay. This does direct object matching on the top level. So here I've got a list of lists. And I say, hey, how many times does Emma appear? Well, Emma, all by itself, the string Emma does not appear at the top level within this list. So it's going to say you get back a 0. And then, but I can say, okay, what about this object, Emma and 1.68? That appears 1 time. Okay, and if I say Emma 1.8, that doesn't appear. Okay, so it's looking for an exact match, or whatever it is you're looking for. Looking for an exact match. Okay, sort. You take a list and you can call sort, and it will sort it in place. And you can also call reverse, and it will take the existing list and it will put it in reverse order. So if this is fam, starting with Liz 1.73, ending with dad and 1.89, I could call fam.reverse, and it will reverse the list in place. It doesn't print anything out to the screen, it just does it. And if you want to see, all right, what's inside this thing, you can see, oh yeah, it has been reversed now. Okay. So this modifies the list in place. All right. If you call fam.sort on this thing, it's going to say I can't do it, okay? Because it's got floats, it's got strings, and it says I don't know how to. You got words, you got numbers. I don't know how to do this. Okay. So here I've got a list of just numbers, numeric values, and you can mix integers and integers and floats, and you can sort them, right? So here I've got some digits. I'm going to do some digits.sort, and here it puts them in order. So it first came in at 4, 2, 7, 9, 2, 5, 1, 5.1, and 3, and here I get 2, 2, 3, 4, 5.1, 7, and 9. And it preserves the numeric types. The 2, everything else remains an integer, 5.1 remains a float, and it's able to do those kinds of comparisons. And yeah, indeed, I can ask, all right, what is the type on index position 4? And it's going to say that's a float, that's 5.1, so on and so forth. You can also do, you can sort in reverse order, which just means the largest number shows up first. I think this is very straightforward. No surprises here, right? There is a function that is not a list method, and the function called sorted will take a list and it will sort them, but it does not affect the list itself. And I referenced this in an earlier lecture, but the list method .sort takes the list and modifies it in place. Whereas if you just kind of want to see, hey, what does this list look like if I were to sort it? You can call sorted, and it will sort the thing, but it does not modify the list, right? And so these are very similar, but also different functions. Sorted does not modify the list. Yeah.
So do all methods modify the actual object?
Not all of them. Not all of them. And you kind of just have to learn. It's kind of like, when you took a foreign language like Spanish or something, it's like you just got to learn the rules of like this one conjugates this way and this one doesn't. And so, same thing in Python. So there's a lot of methods that do modify things in place. A lot of the base Python ones do. And then when you do like switch to NumPy, they don't. And then like NumPy, if you have an array or something and you want it to modify in place, you have to call, you put in the argument in place equals true and stuff like that. So not all, so yeah, the answer is not all of them. A lot of them do. A lot of the ones I showed you today do modify in place. But yeah, it's just kind of like, this is part of gaining the fluency is learning all of these, what happens when and stuff. Yeah, sorry, there's no universal rule. That's the tricky part of learning a new language, whether it's a foreign language or not. Okay, all right, let's, so that's lists. There are like even more list methods, but I think these are kind of like the primary ones. And again, most of these list methods that I did show do modify in place. All right, here, let's look at strings. And here I want to kind of look at strings and treat them like they are sequences, much like, and so we will see how a lot of times strings are similar, treated similarly to lists, okay? So strings are a sequence, okay? So here we have fruit, the name of fruit, we're going to look at bananas. And so you can say, all right, fruit, position 0, and it's going to treat this as a sequence of characters. And so the character at position 0 is the letter B. Okay, the character at position 1 is the letter A, index position 1. -1 is going backwards, so we're going to get the letter character S. Okay, and then you put in something like a 1.5, and then it says, hey, you can't do that. Indices must be integers and stuff like that, right? Okay, so this is like, basically subsetting a string is very much like, slicing a list, okay? Here is, you can call the length, len is the length operator, and so in the same way, when you call length on a list, it will tell you like how many items are in the list. Same thing with a string, it'll tell you how many characters are in a string. So similar things there. You can subset using slicing. So 4:9, all right, what are we going to get? Are we going to get the letter D or not? Are we going to get the letter, is it going to start with a, what is it going to start with a D, an E? What is it going to start with when I do 4:9? So we have to count like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're going to go E through I when we get this. If I have it correct in my brain, E, F, G, H, I. Okay, and so again, you almost kind of have to think of. So I like to think of the slicing happening at like the location of commas in a list. And so again, with kind of a string, you don't have commas between every single character, but just imagine like you have like a little something in between the characters. And so we're going from the 4th to the 9th there. Okay, -6, we're going to count 6 letters in from the back, which I think will be U through Z. Okay, U, V, W, X, Y, Z. All right, and then here I can say, all right, take the string, go from 0 to 5, so that will go A through E, and then we'll print out that plus an exclamation point, okay? And you can see this is almost in the same way that lists, when you take a list and you do a plus, it kind of just tacks on the whatever it is, the new list to the other end. You know, we're doing the same kind of thing with strings. We're taking the string and we're tacking on whatever this new character or new set of characters are. Okay. One thing about strings, though, that is different from lists is that they are immutable, in that you cannot take, here's the string A through Z here, and I can't say, hey, I want to change the character at position 0, I want to change it to B, right? If you try to do this, Python's going to say you're not allowed to do that. It's going to say string doesn't allow for item assignment, okay? So if you wanted to do something like that, you can subset the string from character 1 on, and then you could tack on character B on there, or something like that. If you wanted the first letter of the alphabet to be B and everything else or something. This would achieve the equivalent of this, but again, you can't just take some kind of string and say, I want to change the first character. All right, let me go ahead and give you second answer. Oh, no. Don't submit your answers, right? We haven't done that. Okay, answer 2 is E. That was a typo. So nobody messed this up. You can fix this right now to E. We haven't. The third answer, it's like sometimes people like immediately click submit and look it up. Okay. All right, so we have that. All right. There's a bunch of methods that go along with strings. These are, so these ones, none of these modify the string. So the lists, a lot of the list methods modified the list themselves, but because strings are immutable, none of these methods will modify the string itself. So you can take the string and you can, you can call .upper, .capitalize, .title, whatever you want, and none of them actually modify the string itself, okay? So .upper makes everything uppercase. So here I wrote all caps stats 21, and I think the name of this class is Python and Other Technologies for Data Science. I don't know, whatever it's called. We're going to pretend that's what it is. Okay, capitalize takes the first character in the string and makes it a capital. Everything else is lowercase. All right. Title case capitalizes the first character after a space or a white space character. So this is not like your style guide, what APA, MLA, and you have like rules about capitalizing titles. What is it? Nouns and verbs get capitalized, but articles and conjunctions don't get capitalized, and prepositions under 3 letters or 4 letters long don't get capitalized, but prepositions 5 letters long do get. I don't remember, right? There's like rules about that, but it doesn't follow that. It just says if there's a space, the next character gets capitalized. Yeah.
So for strings, if you're like trying to like say you're trying to like make the name equal to like uppercase, say name equals name.upper.
Yeah. So if you wanted to change, the name itself, calling name.upper is not going to change it. You'd have to do name equals name.upper, and that will take the current, and basically the way it works is the currently existing object, which is called name in memory. You're going to make that uppercase, and then you're going to, that creates a new object in memory, which is all capitals now, or uppercase. And then you're going to take the name, and it's going to point to that new object. And then the other thing that used to be this, if there's nothing referencing it anymore, then it will get, this object in memory will then get thrown away by the garbage collector. The garbage collector will go, hey, we don't have anything that references this thing anymore, so I'm going to free up this space in memory. Okay. For strings, it probably doesn't really care. I don't actually know the details of the garbage collector, but basically it's like, is anything ever referencing this thing? And if it realizes, okay, sorry, you've been forgotten about, then it gets destroyed from memory. Okay, but yeah, okay. So that's title case. Lowercase makes everything lowercase. And again, if you ask, what is name? Name itself has not been modified. Okay, if you wanted to count how many times a letter appears, you could write a little loop that will say, hey, for every letter in the name, just see if letter is equal to the character E, and then increment our count from count to count plus 1. I could have just done plus equals 1, whatever. And it says, okay, E shows up 5 times. But again, we have this method dot count, right? So remember for lists, we had the dot count. Where did it go? Dot count Emma or dot count A. And it goes through the sequence in the list, and it counts how many times that thing. So that same method appears here. We can say name.count E, and it says, yeah, it shows up 5 times, okay? Dot index, so remember dot index says, hey, what is the index position of this, in this case, this character, okay? And here it's gonna look for index, the first instance of it. There's actually only one instance in name, and it's the A here, and that's index position 2. So it's going to come back and say that's index position 2. These are Boolean values. There's Boolean attributes, like does the string start with or end with a certain character? So does it end with a K? Does it end with an E? Does it start with an S? Lowercase s, capital S, that's going to come back true. Okay, and you can put in multiple characters. So I can say, does it start with a capital S, lowercase t? That's false. Does it start with a capital S, capital T? That comes back true. So just, it looks for that. Let me see if this, yeah, this also works. So so index of the first instance there. All right, and then here it says no substring found if you do that. Okay. You can also create multi-line strings with triple quotes. So here I have a triple quote to open it, space, 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 Miles Chen, space, return, 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 triple quote. Okay, and then when you print it out, it looks exactly kind of how I did it here. So space, 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 Miles Chen, space, and then the returns kind of show up here. You can take a string and you can strip. This will remove kind of leading and trailing white space. So that includes spaces in the front, tab characters, and return new line characters here. If you ask, depending on how it's written, if you ask for the object itself, you can see the new line characters as /n. There is a difference between the way Windows and Unix, Mac systems handle new line characters. So Unix systems generally just do, I might be getting this mixed up. I think Unix systems just do new line characters, whereas Windows do new line carriage return, I think. Carriage return is I don't know, what's the word? It's like a holdover from the days where you had typewriters. So I don't know if you've seen movies where people use typewriters, or I don't know if any of you have got to play with an old typewriter, but you go chugga 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 chugga, and then it goes like ding, right? And then you see the person go, and then they slide the thing in. That sliding back to the original position is the carriage return, and then the new line, when you hit enter on the keyboard, that rotates the little paper drum, so it goes up to the thing. Okay, so in Windows or PC-based systems, enter does two things. It does new line, rolls the paper up, and then does the carriage return. Unix is like, that's just a new line. Let's forget this carriage return business. So yeah, anyway, how it gets stored in certain things. I think Python just treats all of this as new line characters, but then if you take a Word document or whatever, anyway, there's all kinds of stuff happening in there. Okay. I think some of you guys you're already exposed to this in your homework, but you can take a string, you can do dot split. and it will look for white space, and it will split the thing, and it'll produce a list with the different things separate at white space characters. You can also define what character you want to split on. So here I have this string 2, 3, 4, 7, 8, and if I say split on this, it says I don't see any spaces in here. I don't see any white space characters, so it's not going to. So here, this is a list with just one string in it, right? So this is confusing, sometimes hard to read, but this is a list with just one string, and that string is 2, 3, 4, 7, 8. Okay. Whereas here I can say split on that comma character, and then it creates a list of length 5, character 2, character 3, character 4, character or string with the character 2, string with the character 3, string with the character 4, so on and so forth. Okay. There is something called a list comprehension. Okay, because this here is a list of character strings or strings of things, and if we wanted them to actually be numbers, okay, we have to like convert them. And so we can take if we know our strings contain integer values, I can do integer on character 2, and we can do that. And this thing is called the list comprehension. We will look at this later, but I'm going to say basically split the string on the commas, and so the result of this is going to be this, and then we're going to say for each element in this list, take that element and make it an integer. And so now I get a list of the integers 2, 3, 4, 7, and 8, and now I can do stuff like add these values together and things like that. Okay. This is a concise version of this where you start off with an empty list, and then you kind of go through after splitting it on the comma, appending each of these things to the list, integer x. So this will also result in the same thing. Okay, there's a couple more methods. I gave you 2 answers already. Okay, let me give you your third one now. And I gotta hurry up. Answer 3 is A, and that is correct. Okay. We have a couple things. These are also just true/false values. Is alpha does it contain only alphabet characters? Okay, and so name contains the numbers 2 and 1, and it also has a spaces in it. So that's going to return false for is alpha. But ABBA, capital A and lowercase a, or lowercase letters, those are fine. Is alpha, if you have the number 4 in it, that doesn't work. Okay. Here's a long string. I took the lyrics from the song Hallelujah, and you can make everything uppercase, and suddenly it doesn't feel like you're singing anymore. It seems like you're shouting. It's interesting that this is how our brain interprets capital letters now. You can also split. Take this thing and split on space characters. You can also, there's something called split lines, and it will split on new line characters, right? So here, this is a multi-line string, and then it will split on these things. And it's interesting because it notices there's a quotation mark or an apostrophe here, then it does the double quote. But if it doesn't have that, then it just does single quotes, okay? You can also just like anything else, you can count how many times does the character E show up and stuff like that. All right. You can also find where is a particular letter here, okay? And here I wrote a function. Don't worry about this function yet, okay? Here is, lyrics to the song Hallelujah, and we're going to look for the character T, okay? The character T the very first instance of it is, 1, 2, 3, 4, 5, 6. I think it's index position. Oh, wait, what is this? Am I missing something here? 1, 2, 3. So 0, 1, 2, 3, 4, 5, 6. Oh, no, I just can't count. Okay, T is index position 0. Okay, so starting at 0, 0, 1, 2, 3, 4, 5, 6, 7. Indeed, okay? So there's a method called .find, and you're like, isn't that the same as .index? because if you do dot find t, it comes back 7. Dot index t also comes back 7. You're like, hey, that looks like it's doing the same thing. Okay. The difference comes up when you give it a character that doesn't exist in the string. Okay. So if you do dot find, say $, it's going to come back and say, hey, I couldn't find that, and we get a -1 here. So if it comes back with a -1, it means I couldn't find that character in the string. Whereas if you do dot index, you're asking, hey, what is the index position of the first instance of the $? And here it says, hey, $'s not in there, I didn't find it, and you get an error, right? So depending on what you're doing, sometimes you want your program not even to entertain this thing and you want the error. Sometimes you want the -1, right? Sometimes you don't want it to produce an error. So depending on what you're trying to do, think about whether you should use dot find or dot index, because the operations are similar, but one will generally when you encounter an error, the program crashes, right? It's like, I got an error, it can't even run the code after it, okay? Dot find will say, hey, couldn't find it, let's just keep going, okay? Okay, there is the in operator. This works also for lists, but it's just like, hey, is this, in this case, it's a substring. Is A contained in there? Yeah. Is the substring nan contained in bananas? Yes. Okay. What about the substring bad? That is not in there. So you just get trues and falses. Is this contained in the other? You can do comparisons greater than or less than when comparing strings. Again, it's a weird thing, but it's like, is one before the other alphabetically? Okay. So A comes before B in the alphabet. Lowercase a comes before lowercase b in the alphabet. All capital letters come before all lowercase letters. This is how Python has decided the arrangement of the letters go. So capital Z comes before lowercase a. Okay. All the digits come before the capital letters. This is like, does A come before AA in the alphabet or in a dictionary? And it does. And 10 comes before 00 in the thing. Okay, 11 is kind of like if you had the word BB versus BCB and you have to alphabetize these. BB comes before BCB. It just looks funny when they're numbers because we're used to thinking of this as 11 and 101. But it's not 11 and 101. It's character 11 and character 101, which is like character BB and character BCB, or BAB, I'm sorry. BB versus BAB. And BAB comes before BB. So BB before BAB is false. Okay, this is false, right? And then as far as like symbols go, there's no rhyme or reason as far as symbols. So here I said, here's all of these symbols. I just went through the keyboard and I just held down the shift button and I went through the top row, and then I think I tried to just punch everything on the keyboard. And I think basically on the keyboard you get like almost everything that's ASCII, all right, which is our preferred thing. So, it's very America-centric, ASCII is, because foreign languages, even like Spanish, you have like accented characters, right? And those are non-ASCII. That's going to break your thing. It's going to say like, I hate accents and I hate, enye and stuff like that. So, so anyway, this is what we do. And then, so we say, hey, give me the sorted version of this. Again, no rhyme or reason, but as far as like the characters on the keyboard, exclamation point comes before pound, which comes before $, but @ is after a question mark. I have no idea who decided any of these things, right? And then, some of these things like make, in my opinion, like, curly brace comes way at the end, but parentheses come way up here, and then square brackets come between the capitals and the lowercase letters. So it's like, who chose this? But this is how it goes. So, okay, that's it for lists and string stuff. We'll wrap it up here. Homework 2, I think, has been posted, and then I'll also you guys have data camp stuff, and then I'll produce more data camp assignments for you guys. I know we hate this stuff. Okay, all right, we'll see you guys on Wednesday.